Let me guess, you're a developer who's tired of the same old keyboard and mouse setup. Maybe you've tried mechanical keyboards. Maybe you even tried those split keyboards that make you look like you're conducting an orchestra. But have you ever thought about what would happen if we take the race in race condition literally? This is the core of my 10x engineering setup, a Logitech G923. Some people say using a racing wheel for coding is excessive. Those people probably still use IDEs. These paddle shifters control my Vim modes now. Here we have my quad monitor setup, because context switching is bloat. Each one runs a different window manager, because using the same workflow twice would make me a normie. This one's permanently locked to H-top, because I need constant validation that my system is more optimized than everyone else's. But this isn't just another I did something stupid with technology video. This is a story about how I learned Golang, Linux kernel input events and inter-process communication, all while trying to convince myself that spending $400 on a racing wheel was actually a professional investment. Okay, enough yapping for today. Let's start the project. What I want to do is, whenever I'm moving the wheel, rotating it to the right or to the left, I want to change the character under the cursor in Neovim. I'm gonna write this project in Go. I just started learning Go and it's a pretty simple language to learn. In terms of syntax, it's pretty small. I think you can learn it in a day or two, but I believe in order to really understand a language, you need to build a project with it. So I'm going to use Golang, and to really learn it and learn how input events work, I'm not going to use any libraries. I'm just going to read the raw inputs, encode it in binary format. We are going to decode it, try to parse the messages, and then set up a Unix domain socket messaging between my Neovim process and the Go process and send messages between each other and handle them. Let's break down how the system works. As you can see in this diagram, we have three main components. First, we have our racing wheel, which connects through Linux's input system. Then we have our Go program that listens and translates input events and sends byte commands. Finally, we have our Neovim with our Lua plugin integration that executes the commands. This magic happens through Unix domain sockets, which is a local fast communication channel between our Go process and our Neovim process. Now let's set up our project. I'm going to create a directory called racing envim, go into that directory and initiate a new Go project. Now I'm going to add our main.go file. To start, let's just print hello world. Let's make sure everything is set up correctly and move on. Now I'm going to add input directory, which will be responsible for all the input translations. Now let's dive into how we process inputs from the wheel. Our input processing follows a clear state machine. First, we detect and open the device. The input event has a specific structure. To detect the device, we are going to look through dev input events. Then from these devices, we are going to find our racing wheel. Then we handle two types of events, event key and event apps. Event key represents a button event and event apps represents an access change. Each input gets converted into a single byte command, which represents a specific action. These single byte commands will be then transferred to our Neovim process through Unix domain sockets, where it will be handled. Now we need to listen to events and send corresponding byte messages based on inputs. To handle button messages, we are going to use handle button message function, which will receive the event and send corresponding single byte. For access changes, we are going to do the same and call it handle access message. To differentiate between different button inputs, I'm going to create a simple mapping that maps the button to its corresponding event code. In order to turn these raw inputs into something useful, we have to do some sort of parsing. On each button click, the wheel sends two events. First is button press, then button release. Here, we are detecting that the button was released after it pressed to understand if it was clicked or not. Only if it's clicked, then we react to changes. Now we add all the mappings needed to transform our button inputs into a single byte message that will be sent through Unix domain sockets. Now we need to do basically the same for our access changes. Now for access changes, we have different pedals, the accelerate, clutch and brake pedals, and they send values in inverted form. So when it's released, the value is 255, when it's fully pressed, it's 0. To make it more useful and less confusing, I'm going to invert those values. Now, since my racing wheel is very sensitive and sends a lot of events, I'm going to create a function that will help me send messages only when the distance between the current input value and the previous one is greater than a specified threshold. Finally, we can create the function that turns the access input into a byte message. Let me quickly walk you through how our socket communication works. When Neovim starts, it creates a Unix domain socket in a temporary directory and starts listening to messages. When the Go program starts, it expects the path of the socket and connects to it. The Go program continuously listens to input events and sends byte messages through this socket. The Neovim process continuously listens for byte messages, maps them into editor commands, and then updates the editor state. When Neovim closes, we also close the socket and remove the temporary file. First, I'm going to create a channel and start listening to input events in a separate Go routine. Then I'm going to use the temporary pipe path created by the Neovim process to connect to the Unix domain socket. Now I need to continuously listen to byte messages sent by the input event handler and send it through the connected Unix domain socket. This is pretty much it for the Go project. And if you are interested in the Lua part and how I created the plugin to execute these commands, I'm going to put the link of the project in the description so you can check it out and leave comments. If you like the project, please consider leaving a like. And if you have any other ideas of projects or you have some feedback, please leave a comment. I also build these projects live on Twitch, so you can join my streams, ask questions live, and be part of these projects. Thanks a lot and see you next time.